Hello. In this video, we're going to take a look at the Lewis structures for bonding assignment. This assignment assumes that you know how to do Lewis structures for individual elements. If you don't know how to do Lewis structures for individual elements, you want to go back and look at our electrons pack and practice Lewis structures for individual elements, because here we're going to be doing Lewis structures for compounds, and that's much more complicated than individual elements. To get us started on this assignment, we have a brief review over Lewis structures for individual elements. Remember, a Lewis structure contains the element's symbol, and it uses dots to represent valence electrons. Hydrogen is in the first column on the periodic table, which means it has one valence electron. We're going to represent that valence electron with a dot. We will see something similar for lithium, because lithium is also in the first column on the periodic table. Don't let the ions confuse you. What this says right here is our hydrogen has an electric charge of +1. Let's think about how the hydrogen got that way. Students will often say the hydrogen became +1 by gaining a proton, because protons are positive. That won't work though, because changing the number of protons changes our element. If we add a proton to hydrogen, we end up with helium. Okay, so the only way that we're going to get a change in the charge on our atom is by gaining or losing electrons. In this case, hydrogen has lost an electron and has become positively charged. Hydrogen only had one electron to give away, so the Lewis structure for a hydrogen ion with a +1 charge looks like this. All right, same thing for lithium. It only had that one valence electron. How did it become positively charged with a charge of +1? It lost an electron. Okay, I'm going to let you work through the individual examples on this first page on your own. See me if you have questions. All right, the second page is very similar to the first page, but here we're going to look at ions, and we're going to do these Lewis structures individually, okay, before we start combining everything into a compound. So lithium, its Lewis structure is Li, and how many dots? One dot, because it's in the first column. Moving over to the next box, we have fluorine. Fluorine is in the second to last column on the periodic table. I like to refer to it as group 7 because it has 7 valence electrons. So we'll label those here. 1, 2, 3, 4, 5, 6, and 7. These are going to be the reactants for our chemical reaction. These are going to be the products. So this reaction is going to produce a lithium ion with a charge of +1. How did it become charged +1? It lost an electron. How did fluorine become charged -1? It gained an electron. So whereas fluorine, when it was neutral, had 7 valence electrons, the negative ion now has 8. All right, so that's what these structures are going to look like for ionic bonds, resulting in the transfer of electrons. The last 2 pages are practice making these Lewis structures for molecular compounds, and these are the tricky ones. We have some rules here that you can use to help you make these drawings. However, I have also posted my own list of rules called Steps to Drawing Lewis Structure I feel mine are more straightforward. Feel free to use whichever set of rules works best for you. Okay? The end goal here is two things. Number one, we must use the correct number of valence electrons. The second goal is to complete octets. What is an octet? Octet is 8 valence electrons. This is what every atom is trying to do. This is why elements are going to react. They're going to react to complete their octets. Alrighty? Everybody gets an octet except hydrogen and helium. We don't really need to worry about helium, however, because helium is unlikely to react with anything. All right, so here we go. If you look at your steps to drawing Lewis structures, step 1 is to find the total number of valence electrons. Well, here in our first compound, HF, let's look at hydrogen first. Hydrogen has 1 valence electron. There's only 1 in our compound. So hydrogen will be bringing 1 valence electron to the compound. Fluorine has 7. There's only 1 fluorine, so fluorine will bring 7 valence electrons. We'll add those two together, and we end up with 8 valence electrons. So to create this compound, I must use 8 valence electrons. If I use 8 valence electrons, I'll have satisfied number 1. Use the correct number of valence electrons. Step 2 says to put the least electronegative atom in the center. Hopefully you remember your electronegativity trends. Electronegativity increases as we move up and to the right on the periodic table. All right, there is one exception to this rule. The exception is hydrogen never goes in the center. All that means is I'm going to start my compound with fluorine because hydrogen always goes on last. All right, so our next step is to put our hydrogen on there. Now we want to show that these two things are connected. We know they're connected because they have bonded into a compound. Step 3 on our steps to drawing Lewis structure says to put 2 electrons between atoms to form a chemical bond. So there we go. We have that there between the hydrogen and fluorine. This uses 2 of our valence electrons, which means we have 6 more remaining. Do I want to put them around hydrogen, or do I want to put the 6 remaining electrons around fluorine? Hopefully you said fluorine because hydrogen does not need an octet. That takes care of steps 3 and 4 on the steps to drawing Lewis structures. Step 5 does not apply. So moving on to step 6, we're just going to connect the dots of the electrons that form a bond. We're going to connect them into a line, and this line signifies that hydrogen is bonded to fluorine. All right, let's look at another example. This one is from your notes on steps to drawing Lewis structure. Again, we'll start over with step 1. Step 1 says to find your total number of valence electrons, all right? Hydrogen has 1 valence electron. There are 2 hydrogens in our chemical formula. 1 times 2 is 2. Hydrogen will bring 2 valence electrons to the compound. Oxygen has 6 valence electrons. There's only 1 oxygen, so oxygen will bring 6 valence electrons to the compound. 6 plus 2 is 8. So in order to satisfy step 1, I shouldn't say step 1. In order to satisfy goal 1, we have to use 8 valence electrons. So step 1, Find the total number of valence electrons. Good, we did that. We have 8 to use here. Step 2 says to put the least electronegative atom in the center. The least electronegative between these two is definitely hydrogen, but remember, hydrogen always goes on last. So we'll start this Lewis structure with oxygen. And how many hydrogens are we going to bond to the oxygen? 2. We know it's 2 because that's in our chemical formula. The compound here is 2 hydrogens and 1 oxygen. That completes steps 1 and 2. Step 3 is to put 2 electrons between the atoms that are bonded, just like that. That uses 4 of our 8 valence electrons. So now we need to complete octets around everybody that wants one. Do these hydrogens want an octet? No, they're happy with just the 2 valence electrons. So our remaining valence electrons we will put around oxygen. Step 5 does not apply here, so we move on to step 6 and connect the dots that form the bond. All right, that's it for Lewis structures for bonding. If you have any questions, let me know. Have a great day.